For thousands of years, scientists and historians alike have been fascinated with how the ancient Egyptians have moved very large blocks of very heavy stone to the top of pyramids during construction. Evidence has shown that ramps were built for slaves to drag the blocks to such heights. I conducted an experiment to find out what angled ramp would be the best to achieve this, and then repeated it, taking into consideration what it would be like if they had wheels. So before we get started, let me explain the different parts of the experiment. This is the inclinator and is the main part of the experiment, which has an adjustable slope. This is the 1 kilogram load, representing a stone block. The wheel did not arrive in Egypt until 1800 BC, so to reflect this, the block is dragged up the inclinator. This is the ballast, which represents the pulling force of the ancient builders. The ballast bucket is attached by strings to the block. As the ballast weight increases, the block moves up the slope. For the ramp angle 7.5 to 40 degrees, I progressively added ballast into the bucket, using just enough to make the block move 5 centimeters in less than 30 minutes, because in the real world any longer would be impractical. I recorded the rate of the ballast and set the ramp at the next angle, continuing until I had tested all the slopes up to 40 degrees. I then repeated the whole experiment using wheels under the block. It looked like this. These are my results. To help understand the results, I turned the table into a graph. Now, what I was looking for was where the ramp angle is largest to minimise dragging length, but not much more force is needed to move the block. I noticed that around a certain point, 12.5 to 25 degrees, the line for experiment 1 was almost horizontal. This was what I was looking for because not much extra force was needed to pull the block up a steeper ramp angle. So I concluded that 25 degrees was the best angle because it was the steepest ramp angle relative to the pulling force. The results for experiment 2 showed that the pulling force increased evenly with the ramp angle, so any angle is okay. A good scientist knows that one experiment on its own cannot be guaranteed to give a true result. They constantly refine and improve their method. I could do the same by improving in some of these areas. I would vary the material of which the ramp is made of to see if they make a difference in how the weight will move. Next time I would do at least 3 runs to make sure the results are reproducible. And I could try adding coverings to the ramp, such as sand, to see if it makes it slippery or if it acts as a brake. So now the ancient Egyptians would be happy. I'll have a better day with not so much work. So my work here seems also to be done.